Okay, so hello everyone. Today we are having this learning session on the topic Avro with Kafka and Schema Registry. Let's see what it is and what can we learn today. Okay. So these are the contents that we will be discussing today. What is Avro, its advantages, disadvantages, what is Schema Registry, why we need it, how does it look, how can we configure it with the Kafka producer and consumer, and we'll see a practical. Okay, so what is Avro? So Avro is a data serialization system. It provides data structures, binary data formats to store persistent data. So Avro gets used in many systems. It gets used in Hadoop, Kafka, etc. And today we will see its use in Kafka. And in simple words, if I say Kafka is defined by a schema, and that schema is written in JSON. So schema is nothing; it's just like a simple contract which consists of some fields. Say when you're publishing data on Kafka, then you'll be publishing a JSON object having 4 fields. Then you'll be defining that in the schema or the contract, you can say. You will define its name, its data types, its properties like nullable, non-nullable. So whenever you'll be publishing your data, it would get verified by that schema if your data is correct or not, so that we won't be publishing or putting any bad data in Kafka, as that can create problems for its subscribers or the consumers. So to get started, you can simply view Avro as a JSON with a schema attached to it, and we will make it clear with the help of examples in later slides. So as we discussed, Avro is basically an schema. So let's see what are the advantages of schema and how it's going to help us. So data, when you're using a schema, data is fully typed. You can't put any random value in your objects or in the events. And when you're using Avro serialization and deserialization, so data gets compressed when you put it in Kafka. So it lessens your resource usage. And when you're creating an schema, there you can define the documentation as well. Like if in your JSON, there are 2 fields, say name and age. These are quite self-explanatory fields. You're getting the meaning of these, right? But if there's any field which is not very self-explanatory, you need to add some like 1 or 2 liner documentation for it. You can simply put it in the schema, and the user will get a definite idea for that field. And schemas can evolve over time. It's not like that if you have made a contract, then it's gonna last for lifetime. You can't change it. You can definitely evolve it over time, but of course with some set of rules. You can't change anything you like in the schema. There are some defined rules for evolving your schema. We will discuss that as well. So another key advantage of Avro is that it supports like evolutionary of schemas, as we discussed, and it provides compatibility. Like there are different compatibility levels of a schema or a contract that also we will discuss. We will understand those compatibility levels. And Avro supports platform like Kafka that has multiple producers, consumers, which get evolve over time. And Avro schema helps to keep your data clean, robust, and defined. So with advantages, there are certain disadvantages also that will get with Avro. Is that if you have seen the events through some Kafka client that you put in the Kafka, those are very readable events. If you read it in JSON or string, those are very readable. You can directly go to a Kafka tool or connect to a Kafka and read those messages. But when you serialize it using Kafka, that doesn't remains to be readable. You have to deserialize it first to read it. So you'll need some tool. And if we talk about performance, then serializing it and getting your data verified by schema doesn't affect your performance much, unless you're publishing 1 million records per second. Then you might get some performance hit at that time, but it depends upon your use case, how much data you have to put. So on that basis, you can choose this scheme or not. So till now we have talked about what is Avro, what is schema, and what are the advantages we get from it. But there should be a place there we can store those schemas, those contracts. So that place is called the schema registry. Confluent has provided us the schema registry where we can store the Avro schemas for Kafka producers and consumers. So the schema registry provides you the RESTful APIs, or you can say the RESTful interface for managing your Avro schemas. And it also allows you to store the history of the schemas. So whenever you will evolve your schema, you will change your schema, you will be creating a new version. And if your schema is compatible, and whenever you go back to an older version or a version from the history, then you can easily do that just by a click. So, and Confluent schema registry supports checking schema compatibility for Kafka as well, just like we talked about it. So, if you see, normally what Kafka does, Kafka takes byte as input and publishes it to Kafka directly. It doesn't really bother about the validation or the compatibility of the data. So generally, when you talk to third-party systems with the help of Kafka, then there could be some situations where producer might change the contract or the event body at their end, but the consumers are not very aware about it. And if consumers doesn't handle it well, then consumers can break. So for those situations, those third-party communications, we can use this Avro schemas and schema registry to validate our data first and then consuming it so that it doesn't break the systems. And yeah, I think we can move to the next slide. So this is like how a schema registry dashboard looks like. So this is a UI that is being provided by Hadoop. So it has certain sections here. So if we look at this left panel, it shows you the list of schemas. For now, I'm having only one schema here, the test value. So this test tells you the topic in which you'll be publishing the data, and hyphen value tells that this schema is for the data, the value you'll be publishing in Kafka. The same kind of schema you can make for your keys as well. For now, I'm having here only for the value. And on the bottom, you'll be able to see the URL, the global compatibility level, and the schema registry UI version. Well, the concern thing for us here is only global compatibility level, which is backward by default. We'll see what does this mean in the latest slides. And in the middle, you can see the schema ID version, schema ID and the versions. So what does it mean actually? When you will be publishing data with your producer, it won't be taking the whole schema itself, with it till consumer. It will only send the schema ID with it. Okay, this is the event and this is a schema ID which is attached to it. So when the consumer will be consuming the data, the consumer will either be having that schema corresponding to its ID in its cache, or if it doesn't have in its cache, then it will be fetching the schema from schema registry and then will be validating the event if it's valid or not. So and that cache and everything is being managed by the Apache Kafka libraries and Confluent libraries. We don't have to do anything for that. So here, if you see the schema, we are having certain fields, the type, which is record, the name, you can keep anything here according to your topic, namespace, document. So this was a document like I was talking about, where we can define your schemas and your fields well. What does this field mean and what does the schema is about? So if we come to the fields, there's a list where we have defined two fields, name and age, and we have defined their type as well. Name is of string type and age is of integer type. So whenever you'll go and edit this and will try to evolve this, then there will be certain rules that you have to follow while editing, like you can add field with the default to schema. Yeah, one thing that I wanted to tell here, with the type, you can define its nullable and non-nullability property as well. If you are defining a default value here, then that means your field is nullable. If producer don't give it, then also the event would be validated. um, and if you don't provide that default value here, then your field becomes non-nullable. Then producer will definitely have to provide that value. And if you go to remove a field from here, let's say name, and this field is non-nullable, then you won't be able to do that in schema registry. And you can definitely change your order attribute, but you can't change the type of the field. Say I'm having this name here, its type is string, and I'll try to change it to integer, then I won't be able to do that, as that would be the break of compatibility level. So these are the certain rules that we have to keep in mind while we are making the schemas or editing it. So on the second tab, we have info. So this is a bit of more user-friendly way of defining or showing your schema, the name, type, if anything has default value, any field have default value, then it would be shown here, its documentation and the config. So now we have got to the part of the compatibility levels that Schema Registry provides us. So there are 4 compatibility levels: none, full, forward, backward. So none means there is no compatibility. You can do anything with your schema and it is not recommended to be done, as there would not be much meaning if we do that, while doing validation and all. So the another backward compatibility level is forward. So we do it to make sure the last schema version is forward compatible with the new schema. And what does forward compatible mean here? It means data returned with the newer schema is readable with the old schema as well. So if our new schema follows this rule, then only we'll be able to evolve our schema if it has forward compatibility level set here. The another one is a backward one. What does it mean? It makes sure that the new schema is backward compatible with the latest one. And what does backward compatible refers here? It means that the data return, that the data that is already returned with the older schemas is readable with the new schema as well. And the full compatibility level means here is the combination of forward and backward. So this is it. So these are the Kafka configurations that we have to provide in producer while using schema registry and Avro serialization method. So we'll see properties here. So one is the bootstrap servers only, the client ID, the key serialization. For key, I'm using the string serializer here. But for the value, we are using Confluence Kafka Avro serializer here. So all of the events will be serialized using this, and the schema registry URL here. So I was having the schema registry running on my local system. So I'm having this local URL here. So we'll be having same kind of configurations at Kafka consumer side as well. The bootstrap server, group ID, key serialization, the value serialization would be the Kafka Avro deserialization here, and the Kafka registry details here. I think now we are good to go for the practical. Let me just share my screen again to share the schema registry. Okay. So this is a schema registry. This is how it looks. And let's try to edit some things here. And let's check the rules we were talking about. Like this is the integer field. And I'm trying to change the type of this field. So when I'm validating it, it says that schema is not compatible with the changes you have made according to the level you have set. So we are changing it to integer, but let's try to change its top age of maybe employee. Says you can evolve your schema as it's been validated, and now we can evolve it. Seems like something is wrong with the schema registry on my local. But normally you'll be able to evolve it through here. And once you can evolve, it's evolved, you'll able to see the different versions here. Right now the version is 1, and once you'll evolve it, there would be a version 2 here, and a number of versions it can store. And if we get to see the producer and consumer, this is the consumer where we are having the settings discussed. And here I have written a normal, simple, very simple consumer where it will consume the records and will print the key and value. Let's run it. Okay, our consumer is up. Let's go to the producer. Again, it's a very simple producer we are having. On startup, it produces a message where it is giving the age and the name in the event. Also, yeah, we should see this test class. So this is the Avro class that we are having here. This has been generated by the schema that we were seeing in schema registry. So in market, there are many tools which helps you generate this class, and you don't have to write it yourself. And I have attached the links and the commands that you can use for generating this class in the presentation, so we can have a look at later. So this is how Avro class looks at producer's end. Now let's run it. Okay, so if I go in Kafka tool and see the data here, my system is running a bit slow, so I guess you won't be able to see the data in real here as it's a bit slow. Well, this was it, like how you can create a simple raw application of a producer and consumer, and how you can work with the schema registry, and how you can create your Avro schemas and use it with Kafka for validating your data. That can help you to prevent any bad data coming into your system, and preventing the subscribers or the producers also running into bad data. So any questions anyone has regarding this?
Yes, madam, what my question about it is if it is a serialization concept, right? So the data is saved in binary format. Exactly.
Yeah.
Yeah. So again, because a lot of companies out there are using Kafka as a database, right? Time
Yes.
series database. So
Yes.
eh,
Yes.
then query is not possible because the
Yeah,
data is saved
correct. Correct. If you're
in
using
binary
Kafka
format.
as a data store, then you won't be able to take the benefit of Avro schemas and schema registry. So if you're using your Kafka for streaming engine only
Yeah.
for messaging system, then you can make use of Avro.
So it is more of an handshake mechanism rather than complete database mechanism. Yeah,
Yes,
so that
correct,
all
correct.
the
For the
consumer and
streaming purpose
everybody.
only, you can use it. For the database thing, if you're using the Kafka, then there is no purpose of having Avro serialization there.
Cool.
Yeah, so I'm stopping the recording now.